Hi, and welcome to the Circuit Breakers YouTube channel. We've been really happy that FTC figured out a way for us to compete this year and have a full season. But one of the things that we've really missed is going to competitions and seeing everybody else's robot and having those teams walk us through a lot of the design decisions that they made. This is a really good way for all of us to learn different techniques on building robots. And so we decided to share our robot as if you were walking through the pits with us. Thanks. Hey guys, what team are you?
We are the Circuit Breakers, FTC117.
Cool. And this is your robot. Could you tell me a little bit about it?
Sure. So our robot can do basically all of the functions in the game. It can grab the wobble. This entire thing is a wobble grabber. And this is the bumper, which prevents it from tilting. So this extends, comes down, grabs it, and we have our wobble. And we raise up all the way and drop it on the outside of the field.
And our intake is also a full robot intake, just like the wobble grabber, and it's a rubber band intake, which gives us a lot of flexibility and it's touch and go.
It also allows us to grab all three rings at once because there's vectoring wheels under, which transfers, it rotates all the wheels into the uplift, which we call it an uplift. So it lifts all the rings up, takes it, and it goes up and up through this, and goes into the hopper.
And then in our shooter,
Why is it named Grace?
Because it's called Grace Hopper. That's Grace Hopper. So she was she's the one who named a computer bug.
Nice.
So, because there was an actual moth in it.
So it's a pun because that's the hopper, so you call it
Yeah.
Grace. Gotcha.
So in our shooter, we have 3 wheels, and we also have 3D printed paint.
Oh, is it under here?
Yeah.
Can we take it off?
Yeah, we can take these screws off.
Oh, so it's so you can get to it really easily?
Yes.
So then it goes through these 3. This wheel is individually attached to a motor with pulleys, and these 2 wheels are connected to another motor, and it just goes like that, shoots out into the...
And you can see that this wheel here we filled with metal to give it more weight.
So it doesn't reduce its velocity when shooting.
And this 3D printed piece right here, we can move up and down to change the
What's on it? It's clear. What is that?
It's silicone tape.
And that can change the stickiness and how much it grabs onto the ring, and that can change how far it shoots to the left.
Well, how do the rings get into it?
So we have a servo with gears here, so it rotates these 2 belts, and these 2 belts carry it all the way into the shooter. And something that's really cool about these is that if it does go off like this, when you rotate it, it just goes back into it. Yep. Like that.
Oh, that's cool.
Yep.
Neat.
And we have 2 servos which lift the entire shooter.
So that's not a motor that's lifting that whole big.
Yeah.
That's like half the robot. So where's the servos that?
So there's one servo here that lifts that gear up.
Oh yeah, I see the little gear and the big gear there. That's a big
Yep.
difference there.
And it
Nice.
and there's one also on the other side.
Wow.
Identical to it.
Over on the other side, we have this, which we call the sweeper. So a lot of rings were going all the way past.
What's that? This? Oh, I see. The whole thing moves.
Yeah. So all the rings were going all the way past us. So this flips out.
And the rings would hit it and then stop.
This is covering your drivetrain. What's going on with the drivetrain here?
So the drivetrain has 2 Omni wheels on the front and back to make it turn easier, and it has a rev grip wheel, traction wheel in the middle for traction. And we have sprockets here attached to each of the wheels to drive it. And there's idler sprockets too to add tension. And under the robot, you can see there would be 2 motors here for these 2 wheels, 2 motors here for these wheels, and that's what powers every the drivetrain.
With
And-
one big chain, huh?
Yep, for each side. And this is our battery holder.
So what do you call these? You were using these for the discs?
Yeah, so it's a variation of mechanism wheels. It's called vectoring wheels. And the difference is that these are more squared off than mechanism wheels. Mechanism wheels are more round. And these are perfect for moving the rings down. So when this spins, it actually, these rollers, what they do is they push it down this way and up into here. These traction start and traction wheels pick it up and then take it in.
Cool.
And then another cool thing is around here. Back over.
You can put it on the ground if you want, guys.
Around here, this half circle, which is a cam down stop, we were having a lot of our shooter moving up and down. So we wanted something that
Isn't it supposed to move up and down?
no, it was doing that because it was going.
Oh, it was hunting?
Yeah, it was hunting, and
Or it was just maybe floppy? Is that it?
no, it was hunting up and down to try to find the right angle, and we wanted to study it as much as we could. So we built this that moves right along with the shooter
When
during a
it's
match.
powered, it would go to the same.
Could you power it on and show me?
Sure. So we will initialize the telegraph.
It's a great example.
Anyway, so pressing play for the teleo, and as you can see,
So you just go up and down? Oh, I see. So it rotates with it and kind of gives it a little bit of a resistance
you
there,
get the
huh?
balance.
Nice. That's cool.
We can show you the rubber band intake too.
Yeah,
and
so
how
we
that-
can.
You wanna put it on the ground?
Yep, we can do that. So the uplift is there, and we will intake it from here. So.
And that's it.
Oh, wow. Nice.
And as you saw, I went through all the stuff.
Can you do another one? Awesome. Well, hey, thanks a lot, guys. Good luck.
Thank you. Thanks for watching, and if you have any questions, leave a comment down below, and we'll make a follow-up video.